Week's presentation of the DBA Fundamentals Group. This week we're talking with Jared Poche on maximizing performance with memory optimized table variables. Checking to see if everything you've heard is right, wrong, or just somewhere in between. Today is February 4th, 2025. In the top right-hand corner of the screen, you'll see the three leaders of the DBA Fundamentals Group: Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. To the right of us, you'll find our Twitter handles. Below that, you'll find various other places you can actually reach out to us on social media. First up is Meetup, where most of us actually found this actual link to get to. Easiest way to find us each week in any of our new presentations. Below that is our website, dbafund.com, where you can find all of our past presentations, links to them, and any of our future presentations as well. Below that is one of my favorite websites, dbafundtube.com, where you can see all of our past presentations, the videos too. Be sure to like and subscribe to our channel, and you can actually learn about these presentations as they become available on YouTube. Below that is some of the other various ways to reach out and see us on social media, on X, Slack, and on LinkedIn. With that, I want to remind you to come to any of the upcoming conferences that hold any value for y'all. The first one is Power BI and Fabric Summit, brought to you by Reserad. It's Global Power BI Summit, February 24th through 28th. So hurry up and get ready for that one. That one is going to be huge. Lots of things about Fabric in that one, obviously, and learning more about Power BI. And below that is one that's near and dear to my heart. March 8th is the SQL Saturday Atlanta, the AI and BI edition, coming up very soon, actually up here in the Alpharetta area, for any of you who know a little bit about Georgia. That's where it's going to be. Be sure to come out to that if you want to soon learn more about AI and BI. Also, remember to turn off your video and mute yourself. I'll be doing that here in just a few minutes. We can all pay attention to Jared. And be sure to type any questions you have into the chat, and I'll relay them to Jared himself. And with that, speaking of, a little abstract about Jared, but I know Jared is going to give more about it than that. So Jared, over to you.
Thank you very much. Give me just a second while I share my screen. Let me see, are you... No, hold on, try that again. All right, technology is being fun today. All right, you seeing this?
Yes.
All right. All right, thank you very much for having me. My name is Jared Poche. This topic is about maximizing performance with memory optimized table variables. I've been a database engineer and now a database architect for a number of years. A little bit more about me. I'm a veteran of Microsoft. I was in support at Microsoft for about 10 years. I've spoken at SQL Saturday events, at Group Buy. I've spoken at PASS or Virtual PASS 4 times, and I've been blogging since 2019. Been a little inconsistent on the blogging. I'm trying to get back on the bicycle on that as it was. I started off working with SQL Server as a community college teacher, basically. I was teaching certification classes, and from there I went straight into support at Microsoft. But I've been working with SQL for 20-ish years now. So this session in particular is going to be kind of intermediate to advanced level. I'm really focusing for high concurrency on some of the things that we're doing. And in particular, I'm kind of assuming, you know, if you're going to try or consider one of the techniques here, we've already made sure we've got, you know, decent indexes on our query, right? We've done some of the obvious stuff and we're not having to deal with basic things at this point. So what I'm dealing with here in some of these suggestions is a little bit more involved. I'm going to show you multiple uses for memory optimized table variables. I'm going to talk about buffer latch weights, which can be a really pernicious thing to reduce. So a couple of ways to deal with those. We're going to talk about a way to eliminate unnecessary DML statements, particularly unnecessary write statements. And we're going to talk about some updates in recent versions of SQL Server that relate to this. So foundations and topics. This talk basically came from a point, uh, from an initial thought of me wanting to take kind of a contrary position here. So I'm talking about memory optimized table variables. Well, table variables in general always get compared to temp tables, and in most of the time that you see people referencing them online on a blog or a discussion board or whatever, they will encourage people away from table variables bad, temp tables good. And the main reason for this is based on statistics and how SQL Server comes up with its estimates and how it generates plans. So we'll talk about that a little bit, but that's kind of the starting off point for this. I use memory optimized table variables a lot. So I kind of wanted to take the contrary position and tell you why memory optimized table variables are good and how you can use them effectively. One of the things we'll talk about in particular is hot page contention. So this is a specific form of page latch contention. There are other forms they also relate to this, but hot page contention. If you have an application that wants to insert or update, a large amount of records on a given table, you can use memory optimized table variables to do that way more effectively and efficiently with less contention and using fewer threads. How do we go about setting something like that up? We will talk about something called the Halloween problem. And it's not directly related, but it comes up with it. Working with that over a couple of years led me to an interesting technique that also can be quite useful in reducing page latch contention. So we'll walk through that. And if you are experienced in dealing with performance tuning, you know what a key lookup is, and you know why they can be rather bad for your performance. Well, here's another circumstance where I'm going to be eliminating key lookups on our say update and delete statements, on some write statements, and using memory optimized table variables, and I'll show you some of the benefits that we can get from it and I've had in the past. And throughout this, I'll be using query store. So anytime I'm giving you hard numbers on something, it's because those numbers came from query store, which I absolutely love. So the main problem, like I said, the first part of the topic came from table variables versus temp tables. And this is quoting from Microsoft's webpage. Table variables aren't supported in the SQL Server Optimizer's cost-based reasoning model. As such, they shouldn't be used when cost-based choices are required to achieve an efficient query plan. Temporary tables are preferred when cost-based choices are required. So when you're using table variables, SQL Server doesn't really have a good estimate of how many rows it expects to get when it queries that table variable. There's no statistics on it like there would be on an index that you have created for a temp table. That's the gist of the problem. That's always been the gist of the problem. And this lack of information, this bad estimate can lead to bad results because it always assumes that a table variable has one row in it. Now, this was changed significantly in 2019, and we'll talk about that more. But this is where the genesis of the table variables bad comes from. So an interesting thing to bring up, and this affects temp tables and table variables because they are both objects that are created in tempdb whenever you create and use a temp table or a table variable. You can run into tempdb contention, and what you typically see is a lot of blocking based on page latch, and the wait resources will be either referencing like 2:1:1, which 2 is representing the database of tempdb. So you'll see weights that are either pointing towards tempdb or the pages inside tempdb. And there have always been three approaches to reducing tempdb contention. One has been turning on some trace flags. This changed some behavior in how SQL Server allocates pages for objects. To create more tempdb files, there's still contention going on, but the contention will be spread across more specific GAM and PFS pages across more files, or simply to create fewer objects. And this is the one that doesn't like get stated as much, I think, in blog posts or whatever you see on the subject of tempdb contention. Maybe just create fewer objects in tempdb. Sometimes that really is the answer. There have been changes in recent versions of SQL Server that make this better. 2016 setup will kind of prompt you to create multiple tempdb files when you are installing SQL Server. So that by itself is an improvement, but a modest one. In 2019, they memory optimized the tempdb metadata. Now that means specifically like the system tables and stuff in tempdb, kind of the schema parts of tempdb that are provided by Microsoft. Some of them are memory optimized, and that reduces some kinds of contention. And I think I've got a link or two here and later that will give you more information if you're interested. Shared GAM and SGAM updates in SQL Server 2022, as I think they've said in Microsoft documentation, virtually eliminates tempdb contention. So if this is something that you're running into, be aware of these. But like I said, this affects both table variables and temp tables, but not memory optimized table variables. And I've got some case studies I've got sprinkled throughout. I can't show you hard numbers for these, or I can't show you, say, screenshots for these from my previous employer. Here was an example where I just replaced temp tables with memory optimized table variables. We had a complicated stored procedure that had multiple temp tables in it. We run a big query at the beginning of it to populate the first temp table. There are many updates based on different steps of logic that then update that main temp table. Significant buffer latch waits throughout this. Well, I went through this stored procedure and I didn't really do much to tune the procedure itself. I basically just replaced the temp tables with memory optimized table variables. I did change, so one of those updates, I just added it to the original insert that populates the table by adding one more join to it. Other than that, the procedure was the same. But because we were having tempdb contention, and we went from having a temp table to a memory optimized table variable, that reduced the duration of this stored procedure by 50 to 60%. This is just an example of the sort of thing I've seen and what's possible with using memory optimized table variables. One of the other things I mentioned specifically, and there will be an example of this later on, is you can write stored procedures to do bulk operations, and specifically address things like hot page contention. So let's say you need to insert 1,000 rows into a given table, a table that has a lot of operations against it. You can either write a stored procedure and have your application call it and give it the parameters and insert one row at a time, and you can have it make, the application can do like 10 or 20 threads and get these in as quick as possible. And of course, since they're all inserting into the same table, they're going to block each other. They're going to step on each other's toes. And you will have page latch contention, which is contention on pages that are already in memory. And obviously, memory access is faster than disk access, but that doesn't mean it's instantaneous. That's what's so difficult to deal with sometimes. We're already dealing with very small or very fast operations to begin with. But if you've got 50 threads trying to insert into the same object, it doesn't scale well. Well, the alternative is you could make a stored procedure that takes a memory optimized table variable as input, and you can give it 100 or 1,000 rows in that memory optimized table variable. It takes less database time to do one operation with many rows. It takes fewer threads on the database and the application side to accomplish this. There's less blocking and latching if you don't have this working across multiple threads. Fewer round trips, and that's not something you're really going to see in the, from the time or in query store or on the database side to begin with. But if we're doing this in one round trip between the application to the database and not 1,000, that's obviously going to cut down on the overall time it takes us to do something. The one thing I would say about doing bulk operations like this or making procedures for this is to keep in mind we are talking about memory that we're allocating here to keep all the information from our table variables. So we need to have a reasonable idea of just how large that table variable is going to be and how many rows we're putting in. You really should consider the size of all the fields in your table variable and be considerate of what a reasonable batch size would be. Now, I heard a chirp. Do we have a question or something? We do not, I think. All right. Here's an example of a basic query. So on the left, I've got a basic query that's just returning information on one order from the sales.order table. And I'm searching for it based on the order ID. So this is how you would normally write a basic query in a stored procedure. Well, what if you want to have a query that returns information on a lot of orders, say all the orders for a given customer in the last month? Well, you can write a stored procedure that's based around a TVP. And your query is going to look like this. Here, I'm joining from the order TVP back to the table, the base table itself. And I've got highlighted in there the where clause, which is commented out, because I don't need a where clause in my bulk query. Looks a little weird the first time, but my filter is effectively the TVP itself. We're joining from that based on the order ID that's provided in the TVP to the base table. That's how we filter it. That's how we tell it what rows we want out of our sales.order table. Now, here's an example of an execution plan where we're using this, but things have gone wrong. SQL Server's gotten the wrong end of this. We've got a merge join between two tables. That's not the problem. The problem is the order in which it's doing things here. It's doing a clustered index scan on sales.order. It's reading the whole table and then joining that to an index scan for our TVP. Well, logically, I want it to go in the other direction, right? I want it to look at the 100 rows in my TVP and then join across and just get those from the base table. So one of the things I will do, and I'm I'm a lot less nervous about using these sorts of hints than I used to be. I will frequently put a join hint in here, and I'm telling SQL Server two things. Use a loop join here, because I know my batch size. I know we're only going to be doing 100 rows here. Please don't build a hash table. That's not helpful. But two, I'm telling it to join in this specific order. Because I've told it which join to use, it's got to use the order that I have provided for this query. Alternatively, you could use the hint to force the join order instead. But I will very commonly do these when I have queries based around TVPs, because SQL Server can make bad decisions otherwise. And once I know what the good plan looks like, I just rather nail it down myself. All right, so I've got an example that I want to run through with you. So what this is going to be is we're going to do an insert of 500 rows multiple ways, and we're going to see the difference between them. So first, I want to create a schema, a table, and a basic stored procedure that's just going to, it's going to insert the data provided, insert one row into this table. That's about it. Good. This is a stored procedure that's just going to create a wrapper for the previous procedure. So this is going to generate random data for us and then call the single insert. So the single insert procedure is all it's going to be doing is inserting the one row. It doesn't actually create the data. Now I'm going to create a memory optimized table type with the same fields, and I'm going to create a procedure that inserts data from that TVP into the table. And this is just a script that's generating 500 rows of random data. So I'm going to run this through and insert 500 rows using my TVP. And then I'm going to do the single insert and run that 500 times. Now, as I was writing this, it kind of occurred to me this isn't really a fair test, because my whole point is, what does the contention look like and how much does that affect things? But running the single insert like this, and you might not have seen that go with the number over it before, it's going to run this batch 500 times serially. So it's not like the various threads can interfere with each other. So let's do one other thing here. I'm going to connect using this little tool. Nope, that's not what I meant to do at all. I'm going to connect with SQL Query Stress, and I'm going to have it run that. Let me make sure I'm connected. Are we connected? Yes, we want to be in wide world importers. Cool. And we're going to do this. Let's do this across 10 threads, 50 times, so that'll be 500 inserts. Let's run that. All right, now I'm going to run this BigQuery against Query Store, and it's going to show me how long it took to run each of those procedures. And let's see what we've got. So let's see, is Zoom it working? It is not. Okay, hold on a moment. Okay, let's see if I can get this to behave now. No, we're still doing that. We did this last time. Much better. All right. So I've got 3 different query IDs and 3 different plan IDs, but I've got more rows than that. So what am I looking at here? This is my batched procedure. Okay. Are you guys able to see these numbers at all?
Yeah, we see it.
Okay. So this is the TVP batched. Now the batched execution of this, we're running at one time, we're inserting 500 rows. So we've got, that's interesting. I think I might have caused a slight problem in my test here. Give me a second. I'm going to run this a second time because it looked like I unfairly biased this. Let's see. Go back to Solution Explorer. Okay, we'll just deal with it. All right. If I look here, the batched procedure ran once and it inserted 500 rows. It took 16 milliseconds. And what I'm seeing here is that I actually had a wait for transaction log IO. And I'm wondering if it had to actually grow the size of the transaction log, and that slowed down this operation. Interesting. The second line, you'll notice we've got multiple calls for insert contention, single insert. Well, this one took only slightly longer than the TVP and didn't have any waits. So this is the serial inserts that we did from Management Studio, where it did 500 inserts one after the other. So this executed 500 rows and 500 executions and took about the same amount of time. Typically, this takes quite a bit longer. So, but we had the oddity this time. I spent 13 milliseconds waiting on transaction log IO. Well, these operations only took 16 milliseconds to begin with. So that first one really only ran for 3 milliseconds. And these numbers here, these are all in microseconds. So this 16,000, that's 16 milliseconds. The third block here, this is me running through SQL IO stress. So this is me running the 500 executions across 10 threads simultaneously. And this took 95 milliseconds. This took way longer. And the majority of it, you can see we had multiple different wait types. That's why we've got multiple rows here. We've got a little bit of latched waits, some memory, some buffer IO, but buffer latch waits, 42 milliseconds, where the process took 95 milliseconds on the whole. So comparing the two, and like I said, this is actually an unusual instance of this. I'm trying to see, don't I have a statement in here? I don't remember the statement to clear Query Store. I'd like to run that again, but it's actually a way bigger difference between these two than typical. We're better off doing the insert through the TVP, which inserts all the rows at once on one thread with no contention, than having our application built to just give us one row at a time on each execution. And I do want to point this out again because you can cause yourself trouble with this. Our memory optimized objects do consume memory, and we need to be reasonable in our expectations here. And part of it is if you write a stored procedure to take in a TVP, you can't limit the size of it. You can't, reject the call because they called you with too many lines in it. You have to start off by taking in those inputs and allocating space for them in memory. So you need to estimate the memory usage you're going to use, and you need to be in step with your developers. You actually need to talk to your developers here if you're going to use these kinds of procedures. Consider the column sizes and consider the number of input rows. Are they possibly going to be calling this procedure across multiple threads as well? All those are relevant, and just be suspicious if they are passing in string fields. You really don't want to see any invar maxes in here, right? We don't want somebody inserting entire books on each row. That's going to be a very large operation that's going to consume a large amount of memory, in addition to however long it actually takes to write that data, right? My biggest concern is how big of a memory allocation are we asking for before the stored procedure even starts running? Any questions on that so far? All right.
None showing up.
All right. Little aside here. So the Halloween problem. This is an odd thing I ran into at work. It's something that is not a SQL Server problem. It's a database problem, a database management problem that was found by like IBM engineers in the late 70s. And what the Halloween problem is the possibility for a write operation to affect the same row multiple times. That's bad and not intended. It can affect any DML operation, in particular if you are trying to write to fields that you are querying from and filtering on. And the problem happens when you update a key field in a specific row, a field that is a key field on the index you're using to find it. So you change that first row. Because you've changed its values, it now has to be moved in the index. You keep iterating through the index, you hit the same row again. You update the row again, potentially. That's bad. Now, SQL Server and every other database management system has Halloween protections that prevent the problem. Now, when this starts affecting my performance, because the Halloween problem typically puts a blocking operator, an eager spool or a sort or something like that in the middle of your query. And this is bad for performance. But the point is to separate the read phase of the query from the write phase of the query. The first time I thought I had run into this, I was seeing the performance and wanting to find another way to make it perform better because of the problem that I was seeing. So I came up with this idea of, well, if SQL Server is trying to separate the reads from the writes, why don't I just do that myself? So if you have an update statement that has this Halloween pattern, well, you could actually write the select part as a separate statement. You could write a select statement and get all the data that you need to have and put it into a memory optimized table variable. Include all the calculations and things that you need and filter out any redundant rows. Now you've done the read, it's in this memory optimized table variable. It's going to be fast to access. And then you perform your DML using the memory optimized table variable. You go ahead and do the update based on this information you've already cached. SQL Server doesn't have to do the Halloween protections. Now, this is interesting in and of itself. But the real cool thing that I figured out is when you have these, you can skip unnecessary statements. Now, this might be kind of niche and it might depend on your environment. But imagine if you have a statement that's trying to insert rows into a table, but the row basically already exists. So if you're doing, say, an insert where not exists statement, it's doing a write operation. And it's going to go through and it's going to lock everything exclusively as it's trying to do that insert, only to find out, oh, wait, these rows already exist. And it doesn't actually write any data. So the benefit here is to take an insert, an update, a delete, that doesn't actually affect any rows, or some percentage of the time doesn't affect any rows, and turn it into just a select statement. You run your select, you put your data into a memory optimized table variable, and then you just do a conditional to see, are there any rows actually changing? If there aren't any rows that are changing, you don't actually run the update. You never run the update statement itself. You never apply any update or exclusive locks. You don't block other operations. If the row that you're trying to insert already exists, then you don't need to run the insert. If the row doesn't exist, you don't need to run the delete. And I say this might be kind of a niche thing. It might be an oddity, but in my environment, the last environment I worked, this led to huge benefits because we had data being provided to us by customers, and many times the data was redundant. It was like inventory management for e-commerce, and they were providing essentially the same data about the same products to us all the time. And when you skip an insert, update, or delete statement, you're trading out update and exclusive locks for shared locks, less blocking. You skip trigger executions. This was one I had no idea about. I'd never even thought about. If you do an update statement against a table and that update updates 0 rows, you're still going to run any triggers on those tables, even though you didn't change anything. Because you tried to, it's going to go through and try to do execute any triggers on that table. You skip foreign key validation. That can be really expensive sometimes. It can be the most expensive part of a write sometimes, is it trying to do that assert check to see if you violated the foreign key from the other table that's referencing this table. Well, if you don't actually run the update, you don't have to validate it. And simply, if you're looking at the execution plan for any write statement, if it's well tuned, if you're not doing table scans and stuff, if it's well tuned, typically the most expensive node, the most expensive single operator in that execution plan is the write itself. It is the update operator. Well, we've taken that out of the equation, and we don't involve storage at all. So, a couple more examples. Come on, Management Studio, where are you? There we are. So I've got 2 of these examples for a reason, I'll tell you. All right, so this is again using wide world importers. So this is an example that I made up when I was working on this, creating a couple of table types. Let's see, creating a procedure to update the sales order lines table. Okay, great. I'm doing this a couple different ways. One is using just blindly updating everything. One is doing an update, but just putting an aware clause to not write rows if the data is redundant. And another one is doing kind of the manual Halloween technique. Let's read all the relevant data and put it into our table variable, and then decide whether we're going to do the update statement or not. So I did this example, and I thought it was interesting to put this in here. I'm actually running this 50 times. And I ran this, and let's see. Come on, Zoom. There we go. Excellent. So we've got the update all. This one took longer than typical. Actually, hold on. I don't trust that. Let me see. Can I go through here and yes, let's clear that. I thought I had this in my script somewhere. Sometimes when you do something the first time, it has to bring pages into memory. I'm kind of suspicious that I biased it here. So I'm going to run that a second time. And I'm going to run this query again. Oh, wow, this is very different than I'm typically used to. You got to love doing presentations. So this is the original. This is the update all. This is just going to update every row in here. This takes, total duration is 31 milliseconds. This is across 50 executions. The second is it just has a where clause on it to tell it, well, don't actually update that row if nothing has changed. That took less than 6 milliseconds. So huge difference between the first and the second. Why? Well, because ultimately I made it so we have redundant data, and it's not really writing those rows. It takes us 31 milliseconds to write those rows. It takes us less than 6 to realize we don't need to. And this is the manual Halloween statement. This is us querying the data into the table variable, and then basically doing the conditional to see, oh wait, all the data is redundant. We don't actually need to run the insert. Now, this between those two statements actually took slightly longer than just putting the where clause on here. So this is what I came up when I was writing this presentation originally. It was kind of confounding to me at first, but in this case, having a where clause to update fewer rows is actually quite effective. But I had a previous example that showed a really different approach, and it's going to depend a lot on some of the underpinnings of your database. So I'm going to show you this one. So here, see if we can get AdventureWorks restored in a reasonable amount of time. There we go. Thank you. All right. So I create my file groups, creating some memory optimized file groups here. I'm creating some table types. I'm turning on query store because it's not on by default. And I'm creating a couple procedures, one that just does a bunch of CRUD operations. It'll either run through and try to update rows based on the TVP, or it'll try to update, delete, update some rows, delete others, and either way it tries to do an insert after the fact. The second one, detailed update modified, does the same but using manual Halloween technique. So it'll query the data, cache it in the memory optimized table variable, decide whether we need to do the insert, the update, the delete, yada yada. And here I'm making an operation that is redundant and trying to run that operation using both procedures. Now in this example, let's see, make you a little bit larger, make you a little bit smaller. There we go. Now, in the original, we've got, let's see, we've got the delete operation here. The delete operation, no, delete operation took 93 microseconds. Okay, that one's clearly not a problem. Our insert is similarly very, very speedy. But this update, we do this update, it takes 27 milliseconds. Now, that's not terrible by most standards, but it's way more than the operations on this table. Now, if you look at the second part, you see an insert into the table variable, but you don't actually see my insert into sales order detail because it didn't run. Actually, let me make this a bit larger. But what you haven't said is we have one statement, one conditional where we say where if the current price or the current quantity is null, well, that's a saying, well, the row doesn't actually exist in the base table. No, actually, I got that backwards. If the record doesn't exist in detailed changes, then I think we're going to delete that record out of the base table because it's not in our TVP. So this is the check we do instead of doing the delete statement. And our delete was pretty fast. Here we have the other where we check essentially whether we need to insert the row into the base table. Also very fast. But here's the comparison point. Our update took 27 milliseconds. This conditional and this insert. Here we populate the data into our table variable. That takes almost 100 microseconds. Here we check whether there are any rows in the table variable where the order quantity changed or where the unit price changed. That took 24 microseconds. Previous statement took 27, so 110 microseconds together to realize we don't need to do the update at all. The data that's being passed to us is redundant and we don't need to do this. So this is a very different response than the example in the wide world importers database. So it's not necessarily going to work in every case, but in this case, it had a big difference. Now, could that be because of, well, I'm looking at the execution plan. It's not, say, doing a foreign key assert, or not a branch, but we do have an assert operator here. It could be more because of the number of indexes that are being updated, or something else with the schema for this table. But in this case, we got a big difference by removing those redundant statements. Here's another case study example. So I was looking at a large stored procedure. It's updating one primary table that's really central to this database and multiple related tables. And oddly, we're spending most of our time in this procedure not updating the main table, but updating one of the side tables because it's got really heavy buffer latch weights. And we have a good index on it, and we have a simple execution plan that's really straightforward. So it seems clear to me, and we've got buffer latch weights. So it's a hot page issue, but on an update and not on an insert. So what I did for this was I added the manual hallowing technique. This was another place in inventory management where it makes sense that this is, product information that's probably not changing that quickly. The average execution dropped from 1.4 milliseconds to 0.4 milliseconds. Well, if it only takes 1.4 milliseconds, why are you tuning the thing? Because we were running that 19 million times a day, almost 20. And suddenly, the update statement went from executing 19.9 million times to 33,000 times. So more than a 99% reduction, right? And the reason this took so much less time to execute is because we weren't having all that page latch contention. Another one using the hallowing. So here we are querying data into a memory optimized table variable and kind of using the hallowing logic to begin with. And if the values from the table, we're querying the base table and our TVP and putting that information into the memory optimized table variable. If the data from the table is null, then the row doesn't exist, so we have to insert the row. All I did here was I improved the Halloween logic, and I realized, wait a minute, if we don't need to do anything clearly on the row, then there's no reason to even insert that into the memory optimized table variable. So we were already using that manual Halloween technique here to skip statements. But here I also reduced writing data into the memory optimized table variable by filtering it differently. And it reduced our time by another 25%. I thought that one was hilarious. Really shaving small amounts off of the database at that point. This was an interesting idea too. So adjacent table IDs, key lookups. So here I'm talking about DML operations that are using IDs from a related table. So imagine you have a query that is hitting let's say you've got an orders table and a line item table, right? The line item table, you're doing a query against it, but you're not looking for a specific line item ID. You're looking for an order ID. Well, in that case, you're going to be using a non-clustered index more likely because you're using the ID from a related table, not the primary key for this table. So you're going through a non-clustered index, and then you're doing a key lookup. Well, when you're doing a write operation, if you're having to go through the non-clustered index to get to the clustered index to find the row that you want to update, it occurred to me that we're locking more pages for that. We're locking pages in the clustered index and the non-clustered. And so it's going to be more likely we're going to have contention with other operations or other threads of this same process. So here was an improvement. I created a memory optimized table variable with the line item ID, with the local tables ID, so that when I actually do my write operation, we don't have a key lookup in its execution plan. Fewer pages are locked, and we should have less buffer latch contention. So let's do the 50s and the 60s. Let's see. All right. Here I'm creating a schema, and this is, let's see, is this in wide world importers? Yes. I'm using wide world importers for everything, but I think that one example, we're creating a TVP and a stored procedure that is using that TVP. We're deleting from the sales order lines table, and we're inserting other records into the order lines table. Let's see. And then we've got a wrapper procedure for that. Let's see. Creating a couple of other table types and a second procedure. Now let's see. The first one here is joining from the table variable to the order lines table based on purely what was passed in with the TVP. And the TVP has the order ID and the stock item. So we're joining this back to the order lines table. We're going to go through a non-clustered index for this shortly. And that's how we're doing this operation. And my second procedure is going to insert data into a new table variable and then do the delete based on that. Yes, thank you. So I'm going to test the two of these approaches 10 times. Are we being blocked? What's going on here? That took longer than I expected, longer than I remembered at least. So let's take a look at these two statements. The first statement is deleting from sales order line where we are joining based on the order ID and the stock item ID. This took 81 microseconds. That's way too long. We can do better. We can do much better. The second one joins based on the order line ID, and it takes 60 microseconds. Let's see. And if I look at the execution plan, what do we got here? Now, don't get too excited about the index scan. This is us scanning our table variable, which has, 10, 100 rows in it, whatever it is. A small, reasonable amount, I'm not upset about that scan. Then we do our index seek against order lines using one of our non-clustered indexes, and then we do the key lookup, which isn't the worst thing ever, but if you're really trying to tune this thing as much as we can, I like to get rid of key lookups whenever I can. So in this case, our second delete statement doesn't have a key lookup because we took extra time to do an extra read, stash that information in memory, and then join based on that. And we made our delete operation smaller. Oh, right, we've got more examples. I like giving actual numbers. Here we go. This is another adjacent delete. I think this is a garbage collection process. Everybody understand what I mean by garbage collection, right?
Yeah, sadly, I know too much about garbage collection.
I did my first pass presentation was basically about just that and optimizations that we had done for that. So I'm creating a couple different table types here, one with an invoice ID, one with an invoice line ID, and you can see where we're going, another with transaction dates, and another, here we're just dropping a constraint just to simplify the example. So this is a garbage collection process. So we're deleting old data from multiple tables. Let's see, what is the base table here? Invoices. We're going through invoices. Great. And this is also in wide world importers. So we're going to delete things in the invoices table that are older than the retention period that's provided. The default is 365 days. We're going to do a batch of 1,000 rows at a time. Great. Or 1,000 invoices. So we are going to query invoices and look for the invoice IDs. We're going to throw them into a memory optimized table variable because we need to delete from other adjacent tables as well. So we're going to delete from invoice lines first and customer transactions because they both have foreign keys to invoices. So we have to do this in the correct order. We populate our table variable, we delete from invoice lines, we delete from customer transactions, then we can delete the invoice, right? Right, sounds good. This one is a little more complicated, doing basically the same thing. We're querying against invoices. Then we query again from invoice lines into a second TVP. Then we query from customer transaction list. Why? Because in each one of these now, we have the invoice line ID and the two fields that are primaries for customer transactions. Then I can delete from each table based on its local ID values. So let's do that. And we're going to run both of these 10 times. We're going to tell it to delete 100 rows, delete 100 rows that are older than 365 days, 100 invoices and all the related information from invoices. And we'll do, and I'm rolling back the transaction just so I don't, delete everything. And to give them both the same data to try and delete. And I'm going to do that 10 times for both of them. Sounds good. So let's see what that looks like in Query Store. Okay, I can look at the execution plans later. Yeah, we've got this in order by the statements, so that'll actually be quite helpful. So I've got the two procedures. I've got the invoices, garbage collect, and the adjacent. So the adjacent is where we're getting the local IDs from the other tables. So let's see. Here we're deleting from customer transactions. We've got these two statements. This one took 61 milliseconds. We're deleting from the invoice list. So we're using the invoice IDs. That means we had to go through the non-clustered index on the customer transactions table, find the record, then go find it on the primary key. Then we can actually do a delete operation. That took 61 milliseconds. Here we use the local IDs. That took 28 milliseconds. Not the fastest thing ever, but it is faster, and we saved time on our write operations. And again, that means we're taking fewer exclusive locks, should be less contention if we're doing this multi-threaded. So we've just kind of shrunk the size of our delete operation by doing this. Questions on that?
None so far.
And here again, one thing to keep in mind when I'm doing this, the manual Halloween technique, there is a slight cost to us doing, that is still the wrong button. We are paying a little extra time to do the reads to populate those table variables. And sometimes we're more than paying for it, and sometimes we're not. In this case, if we spend 21 milliseconds populating this, that's actually less than the time, the difference in time between these two operations. We actually gained time here. But even if we didn't, the fact that we're shrinking our write operation can still be beneficial, even if it takes a little more time. Because you're probably, well, in a fuller example, you would see the reduction of contention, and here I wasn't doing that multi-threaded. So a real world example of that same thing, a garbage collection process on one main table and one related table. This is another odd one because 80% of our runtime wasn't deleting against the main table, it was deleting against that secondary table. And we had really heavy buffer latch weights. So the delete was using the related ID. So we're doing a key lookup. We populated a second memory optimized table variable with the local primary key, and we got a 60% duration drop for the entire procedure. This was an odd one because we had a procedure that was doing a delete and an insert against the same table. And I was like, wouldn't that just be an update? And the answer is no, because it was deleting perhaps one set of rows and inserting perhaps another. So even if we changed it to an update, we'd still need to delete and insert. It was kind of confusing at first, but we have an input TVP that's using the IDs from a related table. Same thing, populated a new memory even though we're taking in a memory optimized table variable from the caller, I populated a new one with the local IDs and eliminated a key lookup. Our duration for this dropped from 40 milliseconds to 7. I was rather pleased with that one. Okay, SQL Server 2019 features. So I alluded to this earlier. So if you're not familiar with intelligent query processing, just, pick a slow day, go and read through that, because there's a lot of really cool things in intelligent query processing in general. But this one, table variable deferred compilation. This is an interesting read, and this relates to what we're doing. So this improves the performance of queries referencing table variables, because during optimization and compilation, it uses cardinality estimates that are based on the actual table variable row counts. So what it does is it doesn't completely compile this statement until the first time it runs. So even though we don't have statistics, quote unquote, on our table variables, this compiles that statement based on a realistic number of inputs. So this eliminates the big reason why people say table variables are bad and temp tables are good. Now, so this to me is really important. I still probably wouldn't use table variables by themselves. Table variables don't have indexes on them, where temp tables you typically will do that. But if I can put it in memory, making it memory optimized is a fundamentally different thing. So this is a very important thing. This is one of the reasons why table variables are better. This also means that you can be less concerned with using a table variable in, say, 2019 or later, using a memory optimized table variable. SQL Server should be better at coming up with good execution plans for that. I'm still not going to be shy about putting in, say, a join hint or a for sorter when I think one is necessary, or where it's going to stop SQL Server from running out into the woods on me. Also, the memory optimized tempdb metadata. That's an important one. I'm glad to see, as debilitating as tempdb contention can be, I'm glad to see that they made changes that improved that. Come on, Microsoft, I believe in you. There you go. Very good. So this removes a bottleneck, and this is in 2019, because part of the system tables for tempdb are memory optimized. But there's still an important difference about this. It's tempdb itself. It's the system tables that are optimized, not your temp table. Your temp table is not memory optimized. It's still being written to the disk of tempdb. So that's a performative difference to me. You're actually writing the data to the hard drive, to whatever your primary storage is, while you're doing operations against the temp table. I'm not writing them to storage when I'm writing to my memory optimized table variable. So memory optimized tempdb metadata, good, but don't think that applies to your temp tables themselves. Other things that are related that you might want to read about: cardinality estimation feedback in intelligent query processing in SQL Server 2022. Anything that makes the cardinality estimates better is highly relevant to our interests. Memory grant feedback is another thing that gives SQL Server more information to go on and helps it make better decisions. And optimized plan forming, take a look at all those. Those are good to be aware of. Now, on the performance side, system page latch concurrency enhancements. I mentioned that in 2022 that there is a tempdb improvement. Hold on, let me go back and find that. How exactly was it said here? Shared GAM and SGAM updates. So part of the gist of the tempdb contention has always been, you've got multiple threads that are trying to allocate space for new objects. When you're creating a temp table, you're creating a new physical table inside tempdb. And it has to go through the GAM and the SGAM or PFS pages. I think the PFS page is also involved, but that's why I've got the links for the details here. The GAM, the SGAM, the PFS pages all have to be exclusively locked so that it can make the changes and make the allocations that it needs for your temp table. This now allows concurrent updates to those pages. There's details here. And this is an interesting post. It has kind of the essentials that you need. The second one is more detailed. But the idea, and I don't know how they do this, this actually sounds like magic to me. The idea that they're allowing multiple threads to lock and update the same page, that really sounds like they're doing magic at that point. This is the point where it says that they have virtually eliminated tempdb contention. So that's very cool. And that affects normal table variables, and then that affects temp tables. It doesn't affect our memory optimized table variables because they use different concurrency anyway. But since that's different, you should be aware of that in 2022, and that might, encourage some of you to get things updated. And this talk is a bit wonky, so thank you for staying with me. I hope that you got something useful out of that. I will post on our chat. I've got this presentation up on my GitHub, so you could download the slides and the scripts if you want and go through them and take a look at them in greater detail. And pardon the branding, I haven't exactly generalized this presentation since I was at PASS with it. Any other questions?
None from the group, but I want to thank you for doing this. This has been awesome. So when you're writing out stuff, do you normally say that the table itself is only going to hold like 100, 200?
Yes. Yes, absolutely.
You don't actually think, oh, let's do table variable.
It's a thing you need to think about. In part, and as I said, be real suspicious if the table variable is really wide, you're giving me a ton of fields. But really be suspicious about those string values. You have to stop and think about it to realize how much larger, the average string is versus, say, the average integer. An integer is 4 bytes. That string is 50 characters. Oh, well, it's 50 bytes. Oh, it's Unicode. It's 100. That's a lot larger than the integer fields. So you have to kind of sit down and really think about the numbers there for them to make sense. I have not run into many problems of this sort. But one of my coworkers had commented at one point that they were using this for something, and their issue is they did have a table with really large character strings, and like if they weren't in varchar max, they might have been in varchar like 4000s or something. And in that case, they were finding that they had to limit it to like 10 or 20. Because they had really large data fields coming in. So yeah, there are cases where that will be a problem. In most of the stored procedures I wrote that were taking in TVPs, a row was either 1 integer or 2. Think about it like, hey, show me all the order IDs from this customer in the last month, or show me these specific order IDs. Give me all the details. Well, what's that going to look like? It's going to be the application passing me individual order IDs. That's the entire row. And I can take 100 of those, and that's not even even a consideration. Or frequently, are you passing in like a table ID and maybe an account ID? Okay, 2 integer values. But a lot of the time, I can do 100 or 1,000, and it's very reasonable.
Right, as long as your SQL Server has memory, you should be good, especially with the really, really small tables.
Right, and if it's 2 integer values and you're passing in 100 rows, that's 800 bytes.
which should be next to nothing for it. So
Yeah, it's nothing. But you really have to be careful with those invarchar max fields.
yeah,
And you can still deal with that. You just need to be responsible. And like I said, you can't get into a stored procedure and get into the and then start checking it and say, oh no, this is too large. I refuse. You've already allocated the memory at that point. The application sent you 1,000 rows with invarchar max. SQL Server caught this, allocated all the memory already, and then you enter your stored procedure and can start doing stuff. So this is like I said, you have to be talking with your developers, because if they just throw a nonsensical amount of data in that TVP, you're going to feel it. So tell them there will be no nonsense.
Amen. Hopefully they all catch the idea. Do not mess with, as everything else, don't mess with a table variable, don't mess with a temp table if you're just going to throw junk into it.
Yes. Anything else?
Anyone? While y'all are thinking, because I know y'all are coming up with some great questions, do want to remind you that in just 2 weeks, on February 18th, we're going to be talking with Freddie Santos on seamless data migration to Microsoft Fabric, strategies and best practices. That one should be great because everybody's heard about Fabric and everybody wants to learn more about it and use it. So great chance to do that. Also on March 18th is Jeff Moden with Black Arts Index Maintenance, GUIDs versus Fragmentation. We all deal with GUIDs. Time to actually do some ugliness to them. So by golly, that's what we're doing. And Derek, can you put up your last slide? I think that was the one that had all the links to goodness.
Hold on a second. Let me see.
No worries.
Yeah, this has my Twitter handle, SQL Jared. I have a blog at sqljared.com. You can find me on LinkedIn if you want to look for me. And that's not the one I use here, SQL Jared. And if you want to see this or some of my other presentations and take a look at the examples, chat, yes, there. That's where that is. And of course, that's my blog. Like I said, I was kind of lazy with my blog last year. I'm going to try to do some more with that. And thank you very much. Have a good day, everybody.
Thank you so much. All right. Thanks, y'all. Talk to y'all soon.